Hello everyone, this is Ray Space, Incredible Space Program 1.12 with RSS Interstellar. That's Real Solar System, Real Exoplanets, and KSP Interstellar. And I continue to attempt to go to other planets, in this case Saturn, with advanced vessels using the engines from KSP Interstellar. In this case, we are using the open cycle gas core engine, and open cycle means it's actually spewing out radioactive stuff, so we can't aim the exhaust at Earth. As long as it's not aimed at Earth, it's fine. It's gonna go right out of Earth's sphere of influence because the exhaust is going that fast. But if it hits the atmosphere, that would be bad. So we make sure that we are not trying to aim it at Earth and continue on to Saturn on a transit that will take 1.5 years. However, one of the flaws of this particular open cycle gas core engine is that it seems to lose efficiency depending on how much heat is generated and as it goes along as it gets used. And that sort of makes sense also because it's carrying out the radioactive material. Eventually we will lose radioactive material, and so it gets less hot. Now, even though I was taking my time doing those burns, I had a smaller engine in order to mitigate this effect. I decided that we needed to make the whole thing longer just to fit more radiators to try and cool it so that it doesn't lose efficiency as quickly. So that's why I'm doing that. I made the tanks less wide, made the whole ship longer so that I could fit more radiators, and I put a slightly smaller engine, so now we have a longer burn time. And that's the transit to Mars you saw me flying there, 1.5 years. Takes about 14,000 meters per second if we were doing that instantaneously, which we are not. Here I'm cycling out a little bit, so just holding prograde. I'm using Pekka's warp thrust plugin in order to make this happen, so I've done a previous video on that if you put the module on a particular part, you'll have to edit the config for it. Then you can time warp while the engine is still on, and so I'm doing that. So I lift the orbit up all the way around so that we are higher up away from Earth. That'll make the burns a little bit more efficient, but that costed extra. And here I'm trying to tweak the thrust and also the reactor power to see if I could keep it cooler by limiting the thrust, but unfortunately if you tweak it down too much, it actually loses efficiency when you throttle down as well. So that's sad, because throttling down is basically cooling it down, and it's the heat that is generated by all the radioactive material that gives you your efficiency. So yeah, if you moderate it, then it's not as good. So we head out there. Eventually you can't just keep going around Earth, of course. You can only do that for about 3,000 meters per second, so the rest of the 14,000 meters per second has to be done during escape trajectory. And so here we are. We are on escape. We're headed out, but we're still burning, and it's gotta take a while. You can see the stage time down there is 2 days and, well, right now 9 hours. We still have 72,000 meters per second. It started off with about 80,000. You can see I'm replotting here, and it still is going to take 15,000, basically what it said initially, and that's because we have lost the additional efficiency due to the Oberth effect being close to Earth. We have lost all that, and so all the burning we've done so far has been basically useless. I mean, it's not really useless, but we still have 15,000 left. So this is one of the difficult things. You know, you ask, well, what's the difficulty then if you're using all these advanced engines? So this one starts off with 7,000 seconds of ISP. Well, you see some of the difficulties. One, yeah, it's a powerful engine, but in order to keep it cool, you can't have it be that big, and you can't have a long stage time, and these maneuvers are very difficult to do, and you have to have Pekka's plugin or some equivalent like persistent thrust, that if persistent thrust actually works, that will let you do these long burns. And then you have to understand how to replot them. And I'll probably do a video on how to do the ion engine burns, because that's very difficult. And those can take years, not just days. So yeah, but an additional difficulty is this feature, if you will, of this open cycle gas core engine that is losing efficiency. You can see the specific impulse there is now 5,800, instead of the initial, oh, actually because we have to come out of time warp to get the real number, it's now 5,465. And again, if I thrust limit down too far, it'll start to lose some of that, but actually as long as we're, I mean, the margin is a little bit better than it was initially, but it started off with 7,000 and it's continually going to lose delta V, so that causes problems for my planning. But anyway, here we are out to Saturn, and it's got to take a year and a half. As a comparison, a normal transit to Saturn could be 7 to 14 years. So it sort of depends on how you go about it. 7 years would be normal, but we're going there in a year and a half, so we're headed there very, very quickly. We then have to slow down in order to capture around Saturn, and that's costing 20,000 meters per second now. I dumped some of the food, water, and oxygen so we can manage that a little better. You can see with the diminished efficiency and all the burning we have to do around Earth, we have about 44,000 meters per second right now. And after we use 20,000, then can we go back to Earth very well? That's the issue. And of course, this 20,000 still has to be done higher above Saturn than is plotted. It's right now plotted as if we're doing it instantaneously at periapsis. We are not. So that is an issue. As we turn here high above Saturn in order to try to start the burn. And so I started a little bit early. I could have waited a little bit longer. But here we are, time warping through this burn. And that's about the conclusion. It more or less was done based on number, and I decided to stop it a little bit early so that I could actually finish orbit at periapsis, or close to it. You can see that we're not low over Saturn, and that's because in Kerbalism it says that the radiation any lower than this is really bad. So we're trying to, even though I don't have Kerbalism in right now, I'm just keeping it safe as far as radiation. It would have been much easier to capture if we had been closer to Saturn than being this high up. Here I am plotting out the trip back to Earth and seeing how fast we can get back based on the amount of delta V that we have. And well, there that would take 21,977 ejection plus insertion, but that's 1 year and 244 days. It's possible because, you know, we can dump the food, water, and oxygen, which I'm doing there. We were carrying way more. The total payload mass of this initially was 200 tons, and a lot of that was spare food, water, and oxygen that we didn't really need for the length of this trip. But after dumping it, we still had a certain amount, but because we are high over Saturn, I can set the initial orbit high, and that ends up being beneficial in this case. We are further up in the gravity well, and so it seemed to fit our budget, but again, that's assuming instantaneous burns, so it's not really in our budget. But as far as how bad it is, MechJeb seems to have a very different idea about how bad it is, and it's going to apply an instantaneous burn too, than Transfer Window Planner, which I was using just now. You can see even for a 2.5 year transit instead of a 1 year 244 day transit, it seemed to require a lot more than Transfer Window Planner was saying, and maybe that's because of our high orbit, the fact that the apoapsis is so high up. I thought about bringing the apoapsis down first, but that costs a lot. That's 2,350, and so it's debatable whether that's going to help. I tried to plot it out myself instead of using MechJeb to see if it really would be any help. Presumably Transfer Window Planner was thinking of a circular orbit at this altitude, not the orbit that we have. And I tried to plot it out, but it's really hard to figure out the encounter with Earth, and so I let MechJeb try to do it again, and it does that to basically a 3-year trip back. So it would be a 6-year trip in, well, we would wait a year, so 7-year trip in total. And I have to check whether we can capture. I didn't click include capture burn on the maneuver planner there. So I test out whether we can capture, and well, I'm continuing to tug it, and we don't have that much. So that is not working out. We can't go like that. And one of the problems was it had plotted a route that was going within Venus's orbit. That's not good. We want to have a plot that has a high apoapsis that'll speed us up going in, but doesn't actually cut within Earth's orbit that much. So that one that I just plotted was only 15,000 total, or about 16,000. I try for something a little bit more ambitious here. This is a 3-year journey that is taking about 19,000 altogether. And here I'm hoping that the food, water, and oxygen consumption will help us out. But really, that's probably cutting it too tight. Especially since by the time we get back to Earth, we're not going to have the same efficiency as we do right now. So this is a flawed concept here, but anyway, 12 hours of burn time is still a lot. We now have a 4,200 second specific impulse with this engine, so that's not great. But here we go, trying to get back to Earth. And finally, the orbit comes in. You can see we have about 4,400 meters per second indicated there, and that's really not enough. But this is the problem. I didn't really know how bad the specific impulse situation would be. Otherwise, of course, 80,000 meters per second, if you tally up all the burns that we've done in the video, 80,000 meters per second would have covered it. So the amount that we started off with would have covered it. It's this whole business of its efficiency going down along the way that has rather hobbled the situation. By the time we get to Earth, we, instead of having 4,400, we have 3,861, and we're down to a 3,791 second ISP. So basically half what we started off with. So half the efficiency. Of course, I'm going to try to dump the food, water, and oxygen. We've arrived. We really don't need that much anymore to see if we can capture, but we can't. So that was the test with the open cycle gas core engine. Obviously, I've learned a few things about it. I can refine this mission in order to make sure that we can get to Saturn and come back. Let's say 2 years there, 2 years back. Maybe even better than that. But for now, I'll leave it here, and next time I will test a different system. So with that, thank you for watching. I hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below, and I'll see you next time.